Welcome back to you all. So today we are going to start our fourth unit, that is sequential logic circuits. Before talking in detail about sequential, I would briefly like to discuss about combinational, and will also like to discuss the difference between sequential and combinational, so that you can develop understanding why we are going to study sequential. Okay, so what was combinational? Combinational was a combination of logic gates, that's all. Okay, and in that case, if you remember, the output was totally depending on the present inputs. Okay, and there was no any feedback also. Mean, if you have given input after to the combinational circuit, you will be getting your output based on the present inputs. Okay, that was simple, that was smooth. But in the case of sequential circuit, we are going to make some changes in the combinational circuit itself. Okay, and then after those changes, the circuit will be considered as sequential circuit. Okay, I have written few differences here, the basic differences between combination and sequential circuit. That, and the most important difference between combination and sequential is that sequential circuits can store information, but your combinational circuits cannot store information. Okay, so let's try to understand this with the help of block diagram. If I have got a, see here, I have got a block diagram of combination circuits. So in this case, the there will be, you will be giving external inputs to this circuit and you will be getting outputs. Okay, so that is simple, as I have told you. But now what I am going to do, I am going to make some changes in this. Here I have got a memory element. This memory element is also designed with the help of combination only, but as of now we'll discuss about that, what is inside this box. But as of now, just consider it as a box only. So here I have got a memory element, and now I'm going to make a feedback path. Now see, the output of this combination circuit is connecting back to the input. Okay, so now this complete structure will be considered as your sequential circuit. Okay, so by adding few more things in the combination circuits, we have got sequential circuit. The what is are the advantages of sequential circuits? We can store, the most important advantage of sequential circuit is we can store information inside a sequential circuit. Okay, so now let's talk about, we are going to start our discussion about the sequential circuit. So for developing a better understanding of sequential circuit, I will start from the basic building block of the sequential. Okay, and for understanding the basic building block of sequential, I am going to discuss first NAND gate. Okay, so let's quickly recall what is NAND gate. So this is the logic symbol of NAND gate. Okay, and this is the truth table of NAND gate. If you observe the truth table of NAND gate, you can see the output of this NAND gate is 1 for these, for 3 combinations of input. Okay, what is common between these 3 input combinations? These zeros, if you see. Okay, so we can conclude that if any input of a NAND gate is 0, its output will be 1. Okay, you have to remember this. Irrespective of the other input, if any input of NAND gate is 0, its output will be 1. We don't have to bother about the other input. Okay, this will help you, this logic will help you in understanding the rest of the things. Okay, so here we are going to talk about now basic storage element. So again, I have taken a NAND gate. I have named it so that I can refer it easily, and I have got another NAND gate. See, NAND 1 and NAND 2, we have got 2 NAND gates. So what I have told to you, what kind of circuits are known as sequential circuit? When there is a feedback. Okay, and that feedback was between in output to input. Okay, so as of now it is combination circuits only. Now what I am going to do, I am going to connect feedback from output to input. See, I have connected output of first NAND gate to the input of second, and output of second NAND gate to the input of first. Now this complete structure is known, may be characterized as sequential circuit. Okay, so NAND gate individually, two sets of NAND gates individually is your combinational circuit. But when I have made a feedback path, now it has become a or a connection between in output and input. So now it has become a sequential circuit. Okay, now let's try to understand the working also. First, I will start with by taking arbitrary inputs as 0, 1, let's say. So what will be the output of first NAND gate? As its one input is 1. Okay, it's a NAND gate and one input of this NAND gate is the input of first NAND gate. One input of first NAND gate is 0. So if one input of first NAND gate is 0, its output will become 1, because we have just seen that if any input of NAND gate is 0, its output will be 1. So here we got a 1. Okay, now this 1 will travel through this path and will arrive at the input of second NAND gate. Agree? Both the input of this NAND gate is 1, 1. What would be its output? Its output would be 0. Okay, so now the first input of first NAND gate, this 0 will travel through this path and will arrive at the input of first NAND gate. Still, in both the input of first NAND gate is 0, 0, so its output will be 1. This process will repeat itself, and this 1 may be considered as latched inside this circuit, and it won't change until unless you are not changing the input. This is why this basic storage element is known as latch. Okay, so we will be using this latch circuit only, and we'll keep on modifying this for designing uh, our memory elements and other the circuits, sequential circuits like resistor and counters. There are a lot other things. Okay, but the basic building block for that is this latch only. So for understanding the working of this latch in a better way, I am taking you to the other slide. See here, I am going to observe the behavior of the circuit for this particular input combination, that is 0 and 1. Okay, so I have again taken the same input. Remember that I will refer the first NAND gate by 1 and the second NAND gate by 2. But you can remember this. The first NAND gate is labeled as 1 and the second NAND gate is labeled as 2. Okay, so keep remember that note representation. Okay, so now here I have got the same SR latch. Just for the sake of simplicity, I will label these inputs also. So I have labeled these inputs as S and R. There is a reason why I have chosen S and R only. You will got to know that. Okay. Furthermore, here I have labeled my outputs also. So you can see that there is a relation between outputs. They both are represented as complement of each other. Okay, so you have to remember that under every condition, your both the output, these both should be complement of each other. Okay, this is, you may consider it as an important or essentials. Okay, these both should always be complement of each other. Okay, so that is how we have labeled input and output. And now let's start our discussion. If I have got S is equal to 0 and R is equal to 1, again we have already discussed this, the same thing will prevails. If one input of first NAND gate is 0, its output will become 1. This one will travel through this, both the input of this NAND gate has become 1, 1, its output will become 0. Okay, so now let's tabulate this result. Okay, at 0, 1 we have got 1, 0. And you hopefully things are okay with you all. Now what I am going to do, see, I'm going to I'm going to change my input. Let's say I am changing my input from 0, 1 to 1, 1. Okay, so the input of first NAND gate has changed from 0 to 1, and input of second NAND gate, it was previously 1 and it has not changed. So this is something very important, and it requires little attention to mean for understanding. So I will request you to please pay your attention. I will be very slow and I will try to elaborate this. In the first, the input of first NAND gate, we are making some changes. Earlier it was 0, now it has, or we want to change it to 1. And input of second NAND gate, that was 1, and we are not making any change in the input of this NAND gate. So every combinational circuit have its own propagation delay. Okay, what is propagation delay? Let's say I have applied an input, whatever time it takes to produce output. Okay, obviously those propagation delay or those time will be nanoseconds only, but there is a time na? And based on that time, mean those time will be different in each cases. Mean if you take every parameter equal, still you can't design two combinational circuits which is having same propagation delay. There must be a small or little difference, and that will be in the range of nanoseconds only. So the thing is, the first NAND gate must be having its propagation delay. The second AND gate will also be having its propagation delay. But we are changing the input of first NAND gate only. We are not changing the input of second NAND gate. See, we are changing the input of first NAND gate from 0 to 1. And we are not changing the input of second NAND gate because it was previously 1 and it has remained 1. So what will happen? Just because of the effect of that propagation delay, the output of this second NAND gate will be available. Why? Because I have not changed its input. So if I have not made any changes in its input, its output will be available. So this will remain as 0 itself. Okay, and by the time this the input of first NAND gate is changing because of that propagation delay, this 0 what we have got here will travel through this. Okay, and this will reach here. So that will make the input of this NAND gate equal to 1. Why? Because one input of this NAND gate has become 0. See, this 0 will travel through this path and will arrive here. So we have got the output of first NAND gate as 1. Why? Because of the output 0 output of the second NAND gate. Okay, so what are the outputs now? The outputs are 1 and 0. So you may conclude that at 1 1 we have got our outputs as 1 0. Hopefully it is clear to all. I will repeat this for next output combination also. Okay, next input combination also. So as of now we have seen when I have given my input as 0 1, I have got 1 0, and after that when I have given my input as 1 1, my output has remained to 1 0. There is no change in the output. Okay, now we can observe there is no change in the output. Okay, now let's observe the behavior of circuit for 1 0. Again I have got the same circuit, S R Q bar, S is 1 and R is 0. Now in this case I will start the operation of this circuit from second NAND gate. Why? Because in this case one input of the second NAND gate is 0 and we have to start with 0. One input of this NAND gate is 0, so its output will become 1. Okay, I don't have to bother about the second input of this NAND gate. One input is 0, its output will be 1. Now again by following the same process, this one will follow this path and this will arrive here. Both the input of this NAND gate has become 1 1, its output will become 0. Let's tabulate this. So at 1 0 we have got our output as 0 1, and now we are going to follow the same process of what we have did earlier. Again I am going to change my input from 1 0 to 1 1. Okay, this is for a reason actually why I'm all the time I'm changing my input from 0 1 to 1 1 or 1 0 to 1 1. Okay, try to understand this. Now again I'm trying to change my input from 1 0 to 1 1. Okay, so in the case of S I am not making any change. Earlier it was 1, now again it is 1. But in the case of R, earlier your R was 0, now we want to change it 1. So again with the same logic, because of that propagation delay, what will happen? the output of the first NAND gate will be available because there is no change in its input. So this 0 will got this 0 here, and this 0 will remain as 0 itself, okay, and this 0 will travel through this path, and by the time this input R is changing, but this 0 has arrived here, okay, and one input of this NAND gate has become 0, its output will become 1. So at 1 1 what we have got here, at 1 1 we have got here 0 1, okay. And if you remember the previous slide, in that when I have given 1 1 after 0 1, in that case I have got 1 0. So if you observe these two, then what is happening here, at 1 1 you have got 0 1, and at 1 1 itself you have got 1 0. So what is this? Actually this is happening because at 1 1 your output is totally depending on the previous outputs only. If previous outputs were 0 1, your output, next output will remain 0 1, and if your previous output was 1 0, your next output will remain 1 0 if you are giving 1 1 as input, okay. So now let's tabulate all the results. So at 0 1 we have got 1 0, at 1 0 we have got 0 1, at 1 1 we have got 1 0 as well as 0 1. So what we can say here, we can collectively write it as no change. So at 1 1 there is no change in the output, okay, and we are left with one possible input combination, that is 0 0. So what would happen in that case? If you are taking S is equal to 0, R is equal to 0, then the input of first NAND gate is also, one input of first NAND gate is also becoming 0, input of second NAND gate is also becoming 0. So both will try to become 1 1, okay. And if these both are trying to become 1 1, I have told you in the beginning that these both output should be complement of each other, they can't be same in any condition. So what we do, we refer this particular input combination as indeterminate, okay. So at 0 0 your output will be indeterminate. There are other reasons also, but that is beyond your scope. So just remember that this 0 0 will be considered as indeterminate. Why? Because at 0 0 both Q and Q bar are trying to become 1, and it's our condition that both should be complement of each other, okay. So this is your latch, and this is the table of your latch, NAND latch, okay. In the next lecture we'll talk about a problem as I have shown to you with latch, and then we'll talk about the flip-flops, okay. That's all for the day. Thank you very much.